Alright, kids, the second part of 9.2, or graphing quadratics in vertex form, we're going to look at two different equations and also the parent function, so three total, where there could be a vertical or horizontal stretch. So looking at the equation alone, how do we know if the parabola is going to be vertically stretched, which is it'll look narrower than the parent function, or if it has a horizontal stretch, so that'll be a lot wider. So let's take a look at example 2, I suppose, in your notes. Alright, so in example 2, here we have our directions. We have to graph y equals a times x minus h squared plus k. So this is vertex form. And the two equations that we have to graph, f of x equals 2x squared and g of x equals 1/4 x squared, notice how we don't have an h or we don't have a k. But we do have a 2 as our a for the f of x, and then we have a 1/4 for our a for g of x. And we're going to see how that affects how that affects the graph in comparison to the parent function. So I'm going to select my points of -4, -2, 0, 2, 4, and get my points 16, 4, 0, 4, and 16. So if you're kind of unsure of how I'm getting these numbers, I'm substituting in -4 into the function for x and squaring and doing the operations that it's telling me to for each of these values of x that I've selected. So I'm going to plot that onto my coordinate plane, and I can't see the -4, +16, so I'm just imagine it's way up here, but I can graph the other points, -2, 4, 0, 0, 2, 4 on the coordinate plane so I can see it. Okay, so I'm going to draw a nice little curve as my parabola. Boom, parent function done. So let's take a look at the first function, f of x equals 2x squared, and I'm going to use the same x points, -4, -2, 0, 2, 4, and substitute those into my f of x. So then I have 2 times the quantity of -4 squared. That'll give me 32. So essentially it's the same thing as x squared, but doubled because I'm multiplying it by 2. So if I do that for the rest of the points, okay, so I have 32, 8, 0, 8, 32, and again I'm looking at these x coordinates as my x, and these are my y's for f of x equals 2x squared when I graph it. So take note, like we have a very large point at -4, 32. I can't graph that, that's way too high. So I'm going to skip that one, and I'm going to go to -2, 8. And so I can kind of get an idea of where 8 is. 8 is, if this is 4, 8's going to be way up here. So I'm going to put a point just on the vertex, which is at 0, 0. And I know that I'm imagining the point was at -2, 8. So I know that the shape is going to be a lot narrower than the parent function. Okay, so then because my graph, its shape is a lot skinnier or narrower than the parent, that's because we have a 2 in front of the x squared. So the fact that we have a value that's bigger than 1, that gives our graph a vertical stretch. Okay, so that's our effect of the 2 with the parent function. So then if I look at the 1/4, g of x equals 1/4 x squared, using the same x values, I'm going to get 4, 1, 0, 1, and 4 when I substitute these x values into g of x. So when I graph -4, 4, which are a lot smaller numbers than 32, 8, and 16 from the previous numbers, I can graph -4, 4, which is right there. So then I have -2, 1, 0, 0, 2, 1, and 4, 4, and you can tell it's still going to open upward. The vertex is still going to be at the origin, except it is a lot wider than the parent function and also f of x. So the reason why is that we have a 1/4 in front of the x squared. Our a value is less than 1. It's a fraction, it's less than 1. So then this gives us our graph to have a horizontal stretch. Okay, so now you know how the value of a affects our quadratic if we have a vertical stretch, so if the a is larger than 1, or if we have a horizontal stretch where our a is, if we have a vertical stretch if the a is greater than 1, and a horizontal stretch if our a is less than 1. Okay, so that concludes part 2 of 3 in our series. So if you have any questions, make sure you write them down, and I'll see you another time.